Can you guys hear me okay?
Yes, ma'am.
Okay, Debbie, is that any better? Okay, all right, good. There we go. So I just got a comment in the chat that it was hard to hear. Well, I have 12:01. Is everybody ready?
Yes, ma'am.
Okay. Do you want me to do the housekeeping first, Lourdes?
Yes, yes.
All right. Well, welcome everybody. We're excited to have Sarah Lower with us today. But before we begin and Lourdes does her introduction, just a couple of items of housekeeping. You do get an HSW credit for today. It was just approved the other day. So if you don't know already, yay, HSW. If you are watching this live, for those of you watching the recorded version, you do not. But you don't need to tell us anything. You don't need to put your number in the chat or anything. Since we did this as a webinar, I have timestamps of you logging in and logging out, and we'll report your credits accordingly. And we do have a lot to cover today. So if you do have a question during the presentation, if you want to put it in the chat or the Q&A box, we'll be taking all questions at the end. So we will answer them and we will get to them, but just put them in the chat and Q&A, or at the end, we will have an opportunity. You can virtually raise your hand and we can unmute you. And that's all the housekeeping I have, Lourdes.
Great, thank you. So welcome to our April Women in Architecture Zoom meeting. Before I do the intro, I'm going to do the sales pitch for next month, which will be May 29th, and we will have a panel discussion on sexual harassment in the workplace, and we will have an attorney, a psychologist, and an HR. So it's a topic that I think everybody is aware of. Sometimes we don't talk enough about it, so we wanted to give us an opportunity. So we will be obviously sending out the announcements and stuff. But now for today, we have something that's very interesting to me, and maybe hopefully to a lot of people as well. And I don't understand it enough, so this will be fabulous. Our presenter is Sarah Lower. She's co-founder and principal architect at LLG Architecture. She's serving currently in the planning committee for AIA Florida Northwest. Thank you, Shadia Jaramillo, one of our committee members, for connecting us. She holds a bachelor's degree in interior design from Florida State and a master of architecture degree from North Carolina State University, where she has received numerous awards from the AIA Triangle components. She's very excited about this technology and not only teaching us and mentoring about it, but sharing her experience, as we have to be very cognizant that technology changes on a daily basis, and what we're building today will not be what we're building in 20, 30 years. So without further ado, please let's hear and welcome Sarah to our April WEAC event. So Sarah, the floor is yours, and we'll take questions at the end.
Thank you so much, Lourdes. Thank you, ladies, for inviting me to present today. I'm really excited about this. This is something that we've been kind of working with and designing for the last 3 years, and it's something that I feel like really is just about to take off. And so I feel like that, especially in the Florida environment and all the things that are going on in Florida, this is a technology that I feel is going to really be more and more up and coming. So today we're talking about 3D printed structures and what's the big deal. You know, architects aren't responsible for means and methods on the construction, so why should we care? But we do care because we are responsible for the health, safety, and welfare of those that are within the structures that we design. So what really quickly, I'm going to talk about our learning objectives, which are brought to you by my daughter. The participants will be able to identify each type of printer currently available, materials used, and the best application for each printer. Participants will also be able to identify the pros and cons of using 3D printing in construction. You guys will also be able to identify key design elements that need to be considered from other construction methods. And participants will also be able to apply current IBC requirements and coordinate with engineers to meet current code requirements, which there is no standard at this time. So just to kind of outline for you guys what we're going to talk about today, I'm going to do a quick introduction. There is so much to cover, but I'm going to try to do it in 15 minutes or less. We're going to talk about the design process briefly, and then I'm going to go into the case studies of the projects that I have been a part of to date. So automation in construction has actually been around for the last 50 years, and people don't know it because it's not really taken off. But it has taken off in the last decade of where robots as prefabrication and factory based robots have really been taking the forefront in the news and what people are trying to do these days. There are over 300 companies worldwide that are involved in some sort of automation in construction, whether they are actually implementing the machines, if they're manufacturing the machines. There's over 300 worldwide. Automation is something that people are looking at these days for several different reasons. There's less injury, quicker completion times. The robots don't get fatigue, they don't get sick. There's enhanced productivity and increased consistency because robots are all about precision. Automation is currently in the United States. They are doing rebar laying and tying, brick laying, marking layouts on slabs. So thank goodness chalk lines are fading out, hopefully. Printing three-dimensional walls, which we're going to be talking about today. And then, of course, there's the security bots that are keeping people, unwanted visitors off the job site. So let's talk about 3D printers. There have been over 100 companies worldwide that are focusing specifically on creating 3D printers for construction. Most of them boast that they can print from 2 to 4 floors high, but only a handful have actually created proof of concept. I know Germany, Saudi Arabia, Dubai, and Canada, just off the top of my head, that have 2 or more stories. You've got 2 basic type of printers, and everybody who's creating a printer is a variation of these 2 things, either a gantry or a robotic arm. Now, the gantry style printer is the printer that you would normally recognize as a desktop printer, something that we've come to see in most offices and what you would see people who buy printers as a hobby use. And so basically they've just taken that concept of the desktop printer and just supersized it. And you could see that. So then the second part is robotic arm printer, and that's where you have them either on crawlers or tracks, and the pump is feeding the robotic arm, and the robotic arm is then creating the formwork or printing the material, if you will. So the big players in gantry printers these days, Icon, which is in Texas, Black Buffalo, which are up in New York, and then Cobod, which is out of Europe. But they definitely have a presence here in the United States. The robotic arm printers, you have Apis Core, Ciba, Vertico, 3D Potter, Mudbots. There are lots of the robotic arm ones. Specifically in Florida, the robotic arm printers that we have here, Apis Core and 3D Potter, are actually being manufactured here in Florida. And there are brokers or general contractors who own a Vertico printer, and then a Cobod printer is also owned here and operated here in Florida. And there's also an AMT printer, which is also another gantry printer that is owned and operated here in Florida. So as far as material goes, the bottom line is the material that's being printed for homes is mostly either mortar or concrete. And these printers are being mixed on site for most part. You have the super sacks that are printed on site, or where you can see that they do 50-pound bags of concrete that go into the mixer that's then brought into the pump and delivered to the material. And then Apis Core actually has a unique idea. They actually thought, hey, let's just do a cement truck. So they actually have a component where the mixture is created in the truck all at once. So you have one big consistent mix rather than the potential possibility of the dry to water ratio not exactly being right every single time. So you have all of these different opportunities and ways to deliver the material to the printer. So let's talk about walls really quickly. So Apis Core put this image together. It is basically a comparison of a wood frame wall to 3D printed wall. Immediately, the first thing you see is the 14 materials versus 6 materials. And immediately my brain goes to, that's the number of trades that are on the job site. That is that less risk opportunity for something to happen to one of those trades that the general contractor then has to mitigate or deal with. The other thing that pops into my mind whenever I see this image is flood damage. So when you have flood damage come through a house, what are the things that you have to replace to mitigate that flood damage? And as you can see on the 3D printed wall, nothing. But on the wood frame wall, there's a whole lot of work that has to happen there. So just something to keep in mind as we look at the pros and cons of 3D printing. And then code. There is no current standard in the ICC that directly talks about 3D printing and what they have to meet. There is a draft that's currently in process, but it is not implemented at all. So over the last 3 years, we have been looking at CMU block or prefab concrete standards that are in the code as to meeting those code requirements in order to get our plans through permitting. And of course, in order to make sure that the structures that we're designing are going to sustain the environment and all the things that they have to go through. Typically, just a real quick idea of the comparison between the two. CMU block code requirements, the walls have to meet 1500 PSI, and typically the walls that we've seen and the tests that they've done on the walls, 3DCP projects are meeting between 4,000 and 6,000 PSI. So they're not just meeting, but exceeding the code requirement. Which is fantastic in areas like Florida and coastal areas that really need to have that durability in their buildings. But again, we have this comparison of how these walls are put together, and it's very much like CMU block. You have the vertical rebar, you have the horizontal rebar with the bond beams. You have the joint ladder reinforcement. You have all of the elements that you would need. The connections from the roof trusses to the walls are already on the market. We're not reinventing the wheel here. We're really using things that are already on the market in a different way, or in a way that will produce in my opinion, a better product. So just to outline the pros and cons here, from my perspective, so we have durability, flood, fire, projectiles. We are able to resist those in most elements. So you have people out in California that are really jumping on this because of the fire resistance. And of course, down here, we really need to pay attention to flood and wind projectiles. Low labor costs. When you have a framing crew out there, you've got 5 to 8 framing crew, depending on the building. Here you can operate the printer with 2 or 3 operators. Less trades on site, which we talked about with the wall construction. A lower safety risk and health and safety on the job site. The best way to reduce risk is to reduce the amount of people on your job site, right? That's just number one. But number 2, when they're not actually using those tools, when they're not climbing up on ladders to reach a really odd, awkward place, they're not putting themselves at risk. There's less waste, all the offcuts of lumber construction. there's less carbon footprint. And the way that we look at this is basically the longevity of the buildings that are being built with 3D printed construction is that you have a typical house that will last 30, 50 years. Well, these homes are looking to last 50 to 100 years. Insurance is a big deal, especially in Florida. And as insurance companies more and more are pulling out of Florida, there's also a statistic that I read last week that said that over the next 5 years, more insurance companies are just going to not renew their policies because of the natural disasters that are happening in the area. And so we need to make sure that we have structures in Florida that can be insurable. And then last but certainly not least, the unique design elements that are possible with 3D printing that, cost less in labor and really the only cost increase is in the planning, the design side. Now, of course, the cons, it's new tech, everything is R&D. So, you never can tell what's going to happen and what the end result will be. You hope that you've planned and thought of everything, but you don't. And then sometimes they just want to try something new and you don't know how it's going to act. So R&D is definitely fun. And then availability, it's not mainstream yet. And so being able to find somebody in your area, like I know that in the state of Florida, there are 5 3D printers currently operating and printing buildings. So, but there are more people are purchasing more and it's coming in. But if you want your project to happen, then you've got to figure out how to get into the schedule of those 5 printers. There's a limited workforce. Nobody is trained to run a giant 3D printer. There's no white papers, there's no education that are turning out tradesmen for this particular construction method. So the people who are running them are people who have been in the ground up, who have worked with the manufacturers of the printers, or the people who have basically taken it upon themselves to learn it themselves. Lacking in standards, again, we've already talked about that. The IBC the ICC and the IBC have not come up with those standards yet. So hopefully when everything gets regulated, then we won't have issues like we had in Iowa where the house was half 3D printed and they had to tear it down because nobody knew what standard they were supposed to meet, and they weren't meeting half of what people were saying they needed to meet. And then of course, price with something new and high demand, you're going to have high price. There's logistics of moving these printers on site and getting them where they need to go. And so price is a factor. I will say that the estimate is as more printers become available, then the price will go down. And that's the prediction. And I am of that opinion as well. So let's talk about the design process that I have uncovered as I've been kind of trial and erroring this for the last 3 years. So the team is critical, and it's set up more like a CM at risk type of team than it is a traditional design bid build. So basically, the team that you need to have at the very, very beginning before you even start your first design is you need to have an owner who's willing to understand that this is R&D, this is something that is new, and they need to be willing to roll with the punches. An architect who needs to be willing to learn as they go. Your structural engineer who is willing to kind of twist and move a little bit more than engineers typically do. A GC who wants to think out of the box, is tech savvy, somebody who wants to move forward into the future. And then the other team member that really needs to be at the beginning is whoever the printer provider needs to be an advisor and a consultant at the very, very beginning, because it is critical that you don't go backwards in your design because you didn't understand everything that the printer can and cannot do. So that brings me to identifying the printer. It is critical to make sure that the printer is identified and determined at the very beginning and doesn't change. I'll talk about a project, our first project that we actually had to change printers in the middle, and it caused all kinds of fun, interesting things. So understanding the availability of that printer. So yes, I want to use this printer, but is it available in 9 months when I'm going to be ready to print? And then, of course, again, I can't say enough, coordinating with a 3D print operator or manufacturer early and often, making sure that we're staying within the abilities of the 3D printer. Printer capabilities. So let's talk about that. So obviously the material is extruding out of the machine. And so there's a question of, is there an over extrusion? If there is an over extrusion, instead of telling me that the beads are going to be 1.5 inches, then you need to tell me that the bead is going to be 2.25 inches, because that's going to determine the thickness of the walls. It's going to affect the cavities. It's going to affect the insulation. It's going to affect the square footage that's usable in the space because of the thickness of the walls. So all of these things are things that we need to take into consideration in understanding that even 1/4 inch extra material could throw a lot of wrenches in the problem. Cantilevering. So when you're doing things like this wall section where your 3D print is actually going at an angle, you need to know how much of an overhang each bead can take, each pass, before collapsing. We need to know those maximum abilities to be able to really create the designs and the movements that we want in the end product of the design intent. Height restrictions. Does your building want to be 2 stories? Does it have, what is it, 1 story, but it has a 2-story element and you want to be able to print that high? All of those things are really important. The printable area. Just because your site says that you have a 50-foot by 100-foot space that you can print doesn't mean your printer has that printable area. And so making sure that your design stays within those printable areas. These are all things that can affect the profitability and even the success of the design intent of the project. So, lastly, on this, on the concept is print sequence. So normally this kind of thing is something that you would see in shop drawings, and it's kind of a gray area that the architect is involved in this. However, this greatly affects the design. If this is not something that is decided during schematic design at the very latest design development, then you're having to go back to schematic design to fix things. I've done that. And so another lesson learned. So even though this is something that is identified, that is the responsibility of the subcontractor, it really is something that needs to be agreed to at the very beginning of the project. And then what I've done is I've come up with a sheet that basically outlines a view of what walls are actually 3D printed, because we do oftentimes have a combination of printed walls and framed walls on the interior. And so what walls are actually printed, and if the printer is a robotic arm, what walls are being printed in what sequence. And that way it's something that we've agreed to at the very beginning. And it reminds everybody on the team throughout the entire process that this is what we're going to do when we get into construction. So I find that this is a little bit of a gray area, but critical in making sure that between the 9 months or 6 months of we designing this and they get on the construction, they don't have some kind of crazy wild idea that they'd like to try, that they're going to throw a wrench in. And maybe they end up doing it anyway, but at least we had a plan and we're working with the plan. So with that, let's talk about case studies. I was the architect on the first 3D printed house in Florida. Since then, that was 3 years ago. Since then, we have had several projects that we've been working in, custom homes. We had an industrial office space that we did a concept for, working with Habitat for Humanity, and just really trying to get ourselves as much experience as we can to better understand the technology and better understand how we can better serve our clients who are wanting to use this design method. So the first project that we're going to look at is the Clay Street project. This is where I pretty much learned to walk on this. It's located in Tallahassee, Florida. We had an array of people working on this project. The general contractor, Precision Building and Renovating, were really the force that got this project off the ground. They worked with the city of Tallahassee to create this opportunity as an affordable house, which we felt like was a really awesome thing, that they wanted the first 3D printed house to not go to an investor, but actually go to a family who needed housing. So I love that. We originally designed this project for a robotic arm print, and because of, lessons not quite learned yet, we ended up having that printer fell through, and we ended up having to use Printed Farms, which is a gantry style printer. And unfortunately, by the time we got to that point, we had already gotten permit and the slab was already poured. So there was kind of a lot of catching up, a lot of calibration, a lot of kind of thoughts of what can we do to fix this problem. So these images are basically looking at what the operator would see. And I just want to point out on this model of what is going to be printed looks different than the model of what we designed. So for one thing, the storage space in the back was outside the print area, so we couldn't print that opportunity. The general contractor ended up building it with CMU block. And then the other part is this part of the house was outside the print area as well as this planter. So the planter did not get printed, and you can see on this diagram, the front part of the house was created as a module. So they angled these in and printed them, and then at the end moved them into place. The other thing that had to happen was they had to do a bunch of calibration. Of course, the slab is already printed, and this image shows how slabs are imperfect, and there always will be when humans are involved. And so they had to do a lot of calibration to make sure that the print was going to be located. The other thing that this picture illustrates is those red dots are where rebar needs to go. And so they needed to make sure that when the printer printed, there wasn't any drippage or anything that would clog up those holes, because obviously those holes had to be drilled before the walls got printed. So those were some of the things that kind of the setup took a little bit longer than anticipated, but they got going and everything looks fantastic. This is a bird's eye view, and you can see just that. This is the slab for the storage out here that is not within the printable area, and then these two portions of the walls that were pulled off of the slab because they were not also able to fit in the printable area. You can also see here, this has kind of grooves in the print, and that allowed for each layer to bond to the next layer. So essentially, when you're talking about 3D printed walls, they are a monolithic concrete wall. Like the entire house is monolithic because it's all printed at the same time and there's no dry joints. So it really reinforces that idea of durability and resilience in construction. So the coloration here, you can see this was day 1, and then this is what they were doing on day 2 whenever they were printing day 2. This image down here also shows how they have the site set up. You can see the super sacks all along back here, with the silo and the pump below it that mixed all of the stuff, all of the material. And there was a really delicate balance between the temperature of the water even to the mixture quantity to make sure that the material was accurate from day to day to day. And this is just another image of them unloading the super sacks into the silo. The last image that I want to talk about on this slide is obviously this was printed in July, and in July in Florida, you know, you're going to guarantee get rain every single day. There were a couple of days where it did rain all day, not just the afternoon shower, but which caused them to have to completely shut down. But whenever they did just have a little bit of a rain delay, they would put this plastic over top of it, which was actually kind of a happy accident. It wasn't on purpose, but it was a happy accident because it kept the moisture in. And there is little to no hairline fractures in the print whatsoever on this print. It was actually just phenomenal and amazing because I've always been told that concrete, there's only two types of concrete that's cracked and concrete that's going to crack. So, so this was a really, like I said, happy accident that everybody was really excited about utilizing for future projects. And then this image is just kind of showing a little bit farther along. You can see inside the cavity how there's, I don't know if you can see at the bottom, but there's actually almost no drippage down at the bottom. There was really no concern on that. But because the only information that we know is CMU block and brick with mortar, and we know mortar drips. And so that was just kind of the concern, but you can see it's very clean in there and very feasible. And then the goal for this project was also to make sure that it fit in with the neighborhood. They wanted to make sure that with affordable housing, that the people who purchased the home felt like they were purchasing a home and not an experiment. And so they finished the house with stucco on the outside and plaster on the inside. So the only evidence of 3D printing is if you were to open the closet doors. So I have just a couple of videos I want to show, and bear with me for a second. So the first video is just showing the printer in itself. You can see the operator has a handheld device that's helping him monitor it, so he can monitor it from his machine, his laptop at the home base, or he can monitor it from his hand by walking around the job site. This is also a really great image to show kind of how the machine moves in tandem, very similar to a desktop 3D printer. And then the next one is, again, the same kind of idea. You can see the machine moving. But I do want to call out this guy right back here. He's doing hose management. Now, Cobot has come up with more new inventions in the last 3 years that they no longer have a problem with hose management, and there's no longer a requirement to kind of buy this silo or rent the silo and do that whole mixing in a silo. They actually have a pump that comes with their machine now. So even in just the last couple of years, there's been more and more advancing in the technology since this project was completed. So, and then I wanted to show you guys quick pictures of the finished product. Again, this is the type of house that with that, you know, even though the corners are curved, that's really the only evidence that you can see that this house is different than all the other houses in the neighborhood. So I'm a little bit behind schedule, so I'm gonna speed up a bit. So I apologize. The next home that we did was Ward Custom Home. This is was a really fun challenge because we had an actual client. It wasn't a spec home for affordable housing, but it was an actual client who was involved in the process as well. We also used a different printer. This printer was printed by Ciba. And again, we actually started off with a different printer, and right before we finished design, that printer was no longer available, and so we had to switch with Ciba. I was really thankful that we were able to switch before we finished out the construction documents and submitted permit, because then it would have been another fun activity. But in the long run, it was good. So these are the renderings that we did for this project, just for you to get a better idea. Here's the project under construction. It's located in Panama City Beach. It's literally less than half a mile from the beach. So again, durability and meeting those strenuous wind loads, wind zones was really critical in this. So the Ciba is a robotic arm printer, and the mix and pumping mechanism is something that they basically had an operator do 50-pound bags, and they were constantly mixing to feed the machine. This is the example of doing like a fun pattern in the wall and how little cost it increased. So this particular pattern, because it's by the water, we wanted to have some sort of wave pattern, and it took about 10% more design because of all of the iterations and everything that we did, but it was only 1% more material to do this pattern on the project. So, I mean, that's a fantastic comparison to understand how much we can do with little labor costs. The other thing that I want to point out is this extra cavity that we have here. So this cavity here is the structural cavity. It's filled with rebar and structural concrete. But one of the things that we wanted to incorporate was, instead of having to use Smurf tubing or something like that to run the electrical, for lighting and electricity, we actually incorporated cavities in the print. And not only was it something that made sure that we didn't miss any electrical outlets that the owner wanted, and having to do like an exterior conduit, but we were able to make sure that everything was incorporated and reduce the cost of the tubing and additional labor that was required when that's done on site. I've got a couple of videos on this one as well, just so that you can see the difference of how this machine extrudes versus the other machine. This machine had very little to no over extrusion at all. I mean, it's just very, very minor. In this video, you can see the owner is sponging the wall before it sets, because she wanted to see if she could achieve a stucco-like look without having to apply stucco to the front of her house. So again, on the job site, R&D. And then here is just a video showing how the operator is able to monitor the machine, monitoring the output of the material, and making sure that everything is running remotely smooth. So the last project that I want to do is one that we just recently finished. This is our third project that we were able to permit. This is located in Melbourne, Florida. This is a 2,100 square foot project. Again, we used a different printer. We partnered with a different printer on this one, Apis Core, which is also a robotic arm printer. And you can see their results. So one of the things that I want to point out in this picture is their printer extrudes like this square extrusion, and then they have a flap on the side here. So you can see on the inside of the cavity, it's a little bit of a curve, but on the outside of the cavity, it's this flat result. Now, Cobot is also the very first printer that we use also has incorporated a flap on there, so they're able to achieve a similar result. But you can just kind of see how the technology has improved in the last 3 years. Again, this project, I want to point out in this image over here, because it's a robotic arm, the span and the ability of the printer to be able to print. So they had the different sequences that they printed. And so this is a sequence that is completed, and you can see how very similar to CMU block, they have this connection at the end of each sequenced print so that they can fill that in and make that a solid wall. Fun features in this one. This is the entertainment area where they have a flat screen TV and, bookshelves and a nice built-in fireplace and mantle. And then they also did I don't have an image of it. They did a 3D print on the ground and then lifted it up almost like lattice to fill this spot here, going from the great room into the hallway here. So one of the fun facts about this project is they were actually able to print this house for about 30% less than the houses that are for sale in this neighborhood. So again, the technology is improving and they're getting there. It just is just taking a minute to do it. So here's a video, and you can show it's a sped up video of how the printer is extruding the material, and the pump is pumping the material to the machine. You can also see the printer is on a crawler, and so once they finish this sequence, then they just move the space to the next location and calibrate it and then get it going again. And then this is a video from the printer's point of view. So you can kind of see how the railing at the top is moving in and out in conjunction with the machine rotating on its axis to be able to print that. And then you can see how they print the interior and then print the exterior. And then this is just a print, so you can see actually in real time what the speed of this particular printer is. So it is a little bit slower. You can also see how that the bar that creates that straight edge is up whenever it's printing the interior of the wall. So selfish plug, I'm just going to show you guys a couple of design concepts that we've done. This is a commercial application for an industrial site. A couple of years ago, you guys know FEMA changed their maps. And so this space went from a mobile office space 3 feet off the ground to now they have to be 14 feet above sea level. And so just imagining what 3D print can do to protect them from flood, to protect them from hurricanes, but also meet those code requirements. And then this is another concept we had for a client that's a beach house. Again, coastal living, we need durability. We need the ability to be able to withstand storms and weather. So this was a concept that we came up with for them of really being able to kind of push the boundaries and what can we do to achieve all of those requirements. So last but not least, I just can't say enough, form your team early, coordinate with your 3D printer operator early and often, identify your print sequence, and then understand your printer's capabilities in and out, all in the very beginning part of your project. I really appreciate this time. Does anybody have any questions?
Thank you,
Oh,
Sarah.
there's lots of questions.
Yeah.
So I'll take a start. So I'm going to try to do these in the order I saw them come in. So Barbara Hughes wanted to ask about the cost of the machinery and the robots. She imagines it's expensive. So does that offset the lower labor cost? and what is the overall net comparison? And you just had a house that you said was 30% cheaper than the neighborhood. So maybe you can talk a little bit about that.
Sure. So you have printers that cost anywhere between $150,000 to $1 million. It depends on what type. I mean, it's like again, because this is not really regulated, because everything has it shaken loose, you have this really big like span of what are you trying to accomplish and what are you trying to do. I know that there's a project that was printed in South Florida. It's a horse barn, and they actually used 2 different printers to print that one. They used the big Cobot printer, and then they used the Vertigo robotic arm printer to be able to meet the requirements, the design requirements of the client. So it really has everything to do with that. I will say the cost of the printer is just like any investment. You know, does upgrading to Revit cost the client more because you have to charge more because you're using Revit versus using AutoCAD that you've had since '99? You know what I mean? It's just that in a bigger scale. So there is really what affects the offset of the labor costs is the logistics, the getting the printer there, the availability of the printer. That is really what is kind of offsetting those costs, which is why 3D printing is now. I mean, the one project was able to do 30% less, but all the other projects that I've been involved in have been more of the ICF construction price versus stick build.
Okay. Barbara also had a question about concrete is known to have a very high carbon footprint. Is there anything being done to mitigate that in the mixed recipes?
Yes, actually, there are. I know Quikrete. I was in a webinar last week, and Quikrete are coming up with a formula that does not have Portland cement or fly ash in it, and so that is one of the things that they're really trying to, as far as materials companies, which is why a lot of times these printers partner with a materials company, so that they can get the best bang for your buck, which. If it's a proprietary material, then that also kind of contributes to the cost issue as well.
So how long does it take to print these homes? And I'll add a second piece to that question. This is from Matthew. Is there a limit to how big that box? I would assume the gantry has a limit, but not the robotic arm. But
agreed.
Okay.
Agreed. So the Clay Street project was printed in 9 days. Again, they had 2 rain days that they weren't able to work at all. And then they also kind of took it a little slow just because this is the first print that they had done. All of those things, again, R&D has a lot to do with those kinds of statistics that aren't able to be like, you can print a house in 24 hours.
Right.
If you hear anybody say that, just ignore them because they don't know what they're talking about.
Okay.
Because a lot of printers want to promote their stuff, and it's kind of a fake it till you make it. So they'll say you can print it in 24 hours, but they don't take into consideration setup time. They don't take into consideration that while the machine doesn't necessarily have to work, your operators do need to sleep. They do need to eat, you know, unless you're doing shift work. You know, it all affects how that is. So it's better when someone talks about days than they talk about hours, because this house in Clay Street, if I get it correctly, and I might be getting it wrong, but I think it ended up being 46 hours, but you can't sit there and say it was done in 2 days.
Makes sense. Irene is asking, how does the 3D printing compare to tilt-up prefab construction?
Very similar. The biggest difference is that with prefab tilt-up, you have all that framework and all that waste that you're creating in that, and you're moving a very big piece of concrete. With the printers that are printing in place, now we did see, you know, the second project that we did, that one was a print the panels and then move them into place. You saw on the first one, the 2 panels that we had to move into place. So that slows your project down time-wise, just because you're having to, and it also costs more on the project because you're having to rent extra equipment. that you wouldn't necessarily have to print. But the third house that we did, that one, they printed everything in place and didn't have to move anything. And so it really reduced, again, the labor, the cost of equipment, and the waste.
The other couple questions, also from Irene, as a matter of fact, how do you account for control and expansion joints? Which kind of ties in the same question. This is from Holly. Are there dimensional tolerances that are greater with 3D printing? So they're kind of, to me, a little bit related.
Okay, so we have not, and I'll have to, admit I'm probably not the best person for that question. I wish I had my engineer on here who could jump in on that question. But we haven't had a situation in the houses that we've designed where we had control joint issues, or have had to incorporate those. And so that's something that just hasn't come up yet. Obviously, we haven't done anything bigger than 2,100 square feet. So that's just kind of where we're at on that. So I'm sorry I can't answer that question better.
That's okay. Somebody wanted to know, how is the plumbing, drainage lines, electrical, and all that stuff integrated within the walls? Because in Tilt-Up, for example, you do. So is this similar to in 3D printing?
So yeah, the same thing that you would do with CMU block, you would run Smurf tubing, PVC pipe. I mean, all of those things. Now, a lot of the designs that we've come up with, we've actually framed most of the plumbing walls, just because either the general contractor was like, I just don't want to tackle that right now. I don't want to deal with that right now, or something along that lines. But I will say that essentially, however you would deal with a concrete tilt-up or CMU block is how you would deal with it here.
Are there any dimensional tolerances or not? I mean,
yes. So each printer, like a gantry printer, has its maximums. So I will say Cobod, I believe their maximum is 38 feet. But they are able to add sections as you go. So you can go all the way up to like 109 feet. It is kind of, and honestly, they say you can go farther, but nobody's asked to go farther. I think there's like a townhome unit in Europe that has used the Cobod at that purpose and had it that long. So with the robotic arm, there is no limitation in printable area. It's really how many times do you want to move the printer?
The resistance of the concrete, do you have to, how does it get tested? How normally you're pouring concrete, you have a little, is that done? How does that work?
So that's on the materials and the manufacturers. A lot of them have actually gotten all that testing ahead of time. And then for the job on site, it's the same kind of thing. Basically, they extrude some of the material in a canister to get that tested. So it kind of works along with the technology and the standards that we already have.
So my question is related a little bit to somebody about the plasticity and the shape. But when I saw the finished product, a lot of it, in a way, looked similar to the neighbors, right? So are you applying then a finished stucco on the outside, and then on the inside, are you squaring off the rooms, or are you leaving that shape, which tends to have those organic kind of rounded edges, to call it that?
Right. So for the most part, we are leaving the rounded edges. We are now, for the first house that we did, they did the stucco on the outside and plaster on the inside. So again, you can't even tell that it's 3D printed. The only kind of hints are the curved corners, which are left in place so that those are the little reminders that this is a different type of house. The very last house, they are not going to finish it with stucco. They've finished it with a sealant, and they're going to leave it as is. And so they're going to say, hey, we're 3D printed and we're proud. So it has everything to do with what they would like to do as a finish, the owner, essentially.
So I'll ask the question that I asked, I think somebody asked a couple times ago, is like, so I want to hang my daughter's picture that she won, whatever, on the inside? It's not a frame wall, so how am I hanging it without putting holes all over the concrete?
Sure, sure. I actually am the one who typed in it last week that said Tapcons.
Yes, at the end.
So
And I was the
there,
one who asked those questions too.
so Tapcons are a very real thing. If you would like to know more about that kind of stuff, actually Icon is the company in Texas. They've actually done videos for the homeowner of how do you patch a wall, how do you hang a wall. But not only are Tapcons kind of an easy thing, but there's also things that you can do. There's a system that you can basically attach to the ceiling, and it hangs down kind of like the way they used to hang pictures
In the museums or something like that.
in museum. Exactly, so that you've got those kinds of picture frames that you can use. But yeah, so for people like us who, if you're like me, I change things all the time. I need to know how to repair that wall in order to move things around. But the average homeowner doesn't move things around as much. And so I think that's really what they're banking on.
Somebody had a question, Jennifer, is there, and of course this is new, any application for renovations, how does that, how do I add to this house? How do I remodel it? Hopefully they'll call you in 20 minutes, 20 years when that happens, but.
Right. Right. So, adding to the house is the same as if you have a CMU block house and you're trying to add to that house. If you're trying to expand, not a problem. Obviously, if there's a wall somewhere on the interior and you want to knock it down, then you're going to have to get a big guy with a sledgehammer and knock it down. A lot of the concepts that we've come up with, though, are open plan, so that the idea is that in the future, if people do want more of a compartmentalized house, you're adding walls and not taking away. And then the other thing is, most people renovate their bathrooms and their kitchens. That's really what they renovate. And so bathrooms and kitchens are set up the exact same way they are now. So it's the same as taking out your cabinets and putting new cabinets in, or reorganizing them in the way that you want your new kitchen.
And two last questions. Oh, sorry.
Mhm.
Is there horizontal printing available, an example for roofs, or is that the next thing? Or is the roofing system still just a wood truss or a precast of some kind?
Right. So that's exactly what it is. We're still utilizing things like precast or quad lock for a flat roof, or now, because this is concrete has to be supported. We can't just have it suspending. And so there are like shapes that we can do, dome shapes, things like that arches that we can print. But there aren't a lot of those out there. There are some examples. There's Big Architects has created a design for a kind of like a hotel in Arizona, that they basically have created kind of like these bungalows that are all dome shaped. And so I would definitely look up and see how they're achieving those. They're not printed yet. So again, proof of concept is not there. However, the ideas are there, and that's really what we need, is more people to come up with these ideas and be willing to jump out there and go, hey, let's try this.
So there's my final question, which is a two-part question. How did you become involved in 3D printing? And does the client find you and say, I want a 3D printed house? Or do you go, hey, do you want a 3D printed house?
I got involved in 3D printing because I made a friend 20 years ago, and he decided to reach out to me. That's really, it's really pure luck is how I got involved in this. It was in a situation where, I didn't have a lot of things going on. I had a newborn, and I was excited to keep my skills up and keep working on stuff. And And it was new and interesting. And then because he was able, that was the Clay Street project. And
Mhm.
because he was able to print a proof of concept and not many people could, people started calling me. And because I had the experience and not other architects had the experience. And so that's really how I've been able to get these projects is either my friend recommended me to someone or they sought out me because they looked to see who was the architect on the project.
Very, very cool. I don't know if you had a chance because you've been answering a lot of questions, but everybody is very much impressed and they think this is awesome. So,
Cool.
it was really, a lot to learn. So thank you so much for doing this. I don't want to use up everybody's time because everybody's busy. So this was a lot of fun. And, we've recorded it. So if you
Absolutely.
guys missed it, absolutely. This is great. So thank you again, Sarah. Thank you, Shadia, for suggesting this.
You're welcome.
Everybody thinks it's very, and I'm sure we will see you again in another setting. And just one last plug, our next meeting is May 29th, a panel discussion. So, and obviously if you have any more specific questions, I'm sure Sarah would be happy to answer them. And if you don't know how to contact Becky, we'll connect you as needed. Becky's like, I got too much to do. Don't give me another something else, but she'll be happy to make
Yeah,
sure if you have any
I
questions.
certainly will. And I think there were a few questions that came in last minute that I will get to you after this, Sarah, that maybe you might be able to answer over email. So I want to make sure we get everybody addressed.
And Holly's
Sure.
gonna
And I
reach
just
out to
put
you.
in the chat my email address. Oh, I
Okay.
spelled my last name wrong. Sorry. I was typing too fast, but it's basically my name, sarah.lower@llgarchitecture.com. And also, if I could do just a selfish plug,
course.
all of the things that I have outlined on this presentation, I'm writing in a series of articles that will be going up on our website. So definitely keep an eye out for those. We'll be posting it on LinkedIn and different things like that as they get released. And so if you guys want to follow us on LinkedIn, you can keep up to speed on what we're doing. And again, I love to collaborate. So if anybody has a client that comes to them and says, we want to do 3D printing, I'm more than happy to collaborate. Even if I'm not the architect on record, I love working with other people. So please reach out to me.
This is awesome. This is very, very interesting. Thank you so much. Thank you, everybody who attended. And I hope to see you soon. And thank you all and see you next month. Thank you much.
Thank you. Bye.
Bye. Very fun. I loved it. It's so cool. Thank you so much.
Absolutely.